Hello, and welcome to the first lecture for CIT 230, Advanced Java Programming. Today's lecture will focus on the concept of encapsulation. In general, we think of object-oriented programming as having three pillars or three constructs that define an object-oriented programming language as differentiated from other programming languages. These three pillars are encapsulation, inheritance, and polymorphism. We'll be studying all three of these constructs throughout the class, starting off tonight by talking about encapsulation. In general, we define encapsulation as the support within our programming language of hiding the implementation of our code from the utilization or consumption of that code, be it a class definition, a method, or some other set of code that we need to access or consume from another area or of code, another application, or other program. We're going to work primarily through an example this evening. I'm going to begin by starting with a very simple class definition for a person. In general, we often use in object-oriented programs common real-life objects or life forms that would be independent actors within an application. For example, if we were making a human resources application or a video game in which there were people inside the game, we might create a person class so that each of the individual people in our organization or within the game could be objects in and of themselves. Because of encapsulation, the properties, which we typically make as private, as you should know from your Introduction to Java class, so that the consumer or the person making objects from your class don't even actually need to know all of your properties. For instance, if I were to make a name property for the first or given name of the person object, I would create a private string first name. Now, an additional benefit other than simply hiding the properties from the consumer, what we are doing here is we are allowing ourselves to protect the data integrity of these properties. For example, if I add a courtesy title, things like Mr., Mrs., Doctor, to my class definition, I don't want to allow simply any value to be in that. And we'll look at that data protection in a few minutes, but it's something you should already be somewhat familiar with from your introduction to Java in a prior course or experience. So I continue to add a few more private properties. I'm going to make this particular implementation of the person class fairly concise. I'm only going to have the 7 properties here because when we work on inheritance next week, I'd like for you to be able to extend the properties to a more specific kind of person, and we'll talk more about that in a future lecture. So these are the private properties of the person object. I'm just using a simple line comment here. Now, one of the things that is primary to the lecture as I'm giving it today is the idea of what we call Javadoc comments. In an intro class, you were made familiar with line comments such as the one I've created here, and with block comments, which start with a /* and end with a //, where we might say something like, this is a simple class definition for a basic person type. With our Javadoc comments, we are going to add a second star to the opening, and this is going to give us the ability to add a number of tags or meta indicators for information very specific to the application for a special compiler called the Javadoc compiler that comes with the Java Development Kit as downloaded from Oracle's website to create documentation that mimics that of the APIs. If I were to go into the Oracle website for Java and open up the API documentation for Java 8, which is what we use in this class, we'll notice a set of libraries or packages. We'll be learning more in a future class about how packages work, how to create them, how to name them, and how to use them for your own programs. And if we go to, say, java.lang, the default API library that we get to utilize for any Java application, we can go down and look at a specific class such as math, which we may have used in the past to do things like take a number to another power or take the square root of something, and we can see a nice set of documentation that shows a representation of static constants that are publicly available. These fields or properties are available publicly, and then here's a list of all the methods that you can use with descriptions, what is returned by them, what are the arguments or inputs to them, so that you know how to use them. We are going to, with the Javadoc comments, produce documentation that looks exactly like this for our own applications, which will be extremely beneficial and is particularly noteworthy for encapsulation. And this is how, or one of the tools we have to be able to hide our implementation while still allowing others to utilize our classes. By this time in your Java development time, you will be familiar with the Java.util class called scanner. Most of you used this in your intro class to retrieve data from the keyboard or to read data out of a text file within your operating system. Here we have the ability to look and see some basic information about the scanner. In this case, it's fairly extensive because the scanner is a more complex class. But down here, we see all of the constructors that are available for the scanner class. And as you probably have already learned, overloading or having multiple constructors is extremely common practice within Java, and we'll talk more about that in our person class in a few minutes. But we also see a set of all of the methods that there are associated with the scanner class. And while most of you will have learned about how to use the scanner class for your own code from a teacher, a textbook, some kind of tutorial, a thing like that, ultimately having this documentation available to you is a way of learning how to utilize any particular class specifically for your coding. So let's go back to our person class. As with the scanner, none of these properties are going to appear in the API or Javadoc documentation, so we won't have to do anything with those here. It is very typical to put a tag that says @author at the top of your code. I'm going to put my name here, and also an @version. Versioning is something that's very fundamental to software development life cycles. Unfortunately, in the 16 weeks of this class, we won't have the time available to us to go in depth into software engineering practices and how we work with versions. But for now, just keep in mind that that we code will have will frequently have versions, and over time we may add functionality, remove functionality, fix bugs, things like that, and that's where the version number is important. All inside of Javadoc comments, you will notice that all of the tags take this @ and some keyword functionality. Inside of the Canvas course shell is a direct link to the Oracle documentation on using Javadoc comments. So you have that at your disposal to learn more in depth about what these tags are. For the purposes of this class, everything that you'll need throughout this course will be covered at least briefly in this lecture, and you'll have an opportunity in the first assignment that you'll receive next week to put this into practice. So in general, by convention, we always put the private properties, the constants, the static constants, the public constants, all of those what we would call global variables at the top of the class definition, followed immediately by the constructors. Now, of note is I can still use line comments for my own particular readability to better be able to read my own code and to help others who come in to edit or update my program in the future. So I like to separate the sections of the class definition with a line comment. So I'm just simply stating that all of my constructors will be in this section here right after the private properties. Now it is very, very typical to create to create a no argument constructor. Often when we are creating objects from a class, we won't exactly know what it is that we want to do, what values we want associated with that object at the time we create it, particularly since it's very common to create all of our objects and variables near the top of our code. There may be other actions that need to be performed before the details can be filled out on the object, so it's quite common to have the creation of a generic object. So a no argument constructor is very common. Anything that is public, and as you probably will have done in any of your intro classes, make all of our methods public. Anything that's public, that's a key that we're going to want to add some kind of Javadoc comment to it. In this case, we just want to describe this constructor, and that will be that it is a no argument constructor for creating a generic person object. So inside of here, we will have first name equals Jane, last name equals Doe, middle name equals null, courtesy title equals null, suffix equals null, gender equals female, and age equals 0. So I have specified some value for all 7 properties of this class. You'll notice that a few of them I did as by assigning them null. Well, one of the things that you may not have learned up to this point is that the reference variable, the any variable created of a class from a class rather than a primitive type. And string, remember, all strings are objects. They are created from a class. So all of these variables are reference variables or variables that contain objects. Primitive types will contain values that are native of that type. When we have a reference variable, but we don't want to have any particular object value in there, we can set that variable to null. Null is a value, and it is the value of the empty object. It refers to any object that, like the non-existent object. Null is the nothing thing. So essentially, we're saying there is no middle name, no courtesy title, and no suffix associated with this object at this time. Those things will be updatable all by using the sets and gets that we should be familiar with by the time we've come to a class like this. Now I'm going to make a second constructor, and this is going to be a constructor that takes in as arguments the most common property values used. And for a person, I'm seeing those as the first name, the last name, the gender, and the age. Quite frequently, particularly in the United States, courtesy titles aren't frequently utilized, but I've included them here because things like courtesy titles and suffixes, which again neither are nearly as common as first and last names or even as common as middle names, I've still included those because it's always good to make our types as flexible as possible to cover the most number of cases as possible so that the class is useful in the most number of other programs. Now, there may be things we leave out for the sake of making this as generic as possible, but there is a balancing game there. I've focused this particular version of a person class on the identity of the object, which is why there are 5 different properties associated with the name or the identity of the individual, and have simply just added a gender and an age onto that to make this fairly basic. But since, as I've just stated, this version of the person constructor is going to take in a value for the first name, a value for the last name, a value for the gender, and a value for the age, I am going to have to make reference here now to those inputs so that I can share with the individual using this application or utilizing this class to create objects and call methods to indicate to them what the inputs look like, and valid values for those that use data protection are. So we will add an @param tag. The first parameter is fn, and this is the first or given name of the person object. We're not going to make any reference at this point to valid values because in this particular case, we are going to allow names to be essentially anything the end user wants them to be, as long as it's a valid string. I look at it as the person may want to be able to, say, use a $sign for the S, as in Kesha, or mix numbers and symbols in like R2D2. Just allowing the user of this class to create objects, to give them that flexibility, and then they can further limit the data that can come in here as they create the objects themselves, or by creating new inherited versions of this class and restricting it there. We'll learn more about some of those concepts in future lectures, but for now, we're just going to keep the first and last names to be whatever it is that the person, the consumer of the class, would like it to be. So I create a different @param tag for each of, oops, there is no middle name in this version, I apologize, for each of the inputs. And this will be sex, which is the gender or sex of the person object. And finally, we're going to do @param age, the age in years of the person object. Now you'll notice that I referred to the age in years. That is my intention as the application or the class designer, that it will be used in that way. By making it a byte, I'm restricting the values that are valid within age by data type to nothing bigger than 128, and so clearly age in days isn't going to be very interesting in this, but the person could, in theory, utilize this age as in months, because rarely do, if this were a pediatric unit or daycare center or something like that, the class was being used for that, the person could co-opt that definition and make it age in months, but by specifically stating that it's intended to be age in years, it helps the user who doesn't see my implementation of what it is that this is intended to be for. Remember, these comments are for external consumption. These are to be used by people who are using your class within their code which is extremely common practice in the real world, where one programmer may be making a set of class definitions that are then used by programmers of interfaces or of other aspects of the code who will only consume this class, and because of the encapsulation, they won't be able to see what all the properties are. They won't be able to verify what is expected or anticipated. Those kind of skills of writing comments that really help the other user to best utilize your class comes with experience, but that's one of the things that will occur throughout this course. Now, one of the things that I find to be critical is explicitly stating for the user what the valid values for this variable in the context of this program, this class definition, that for the intents that you are creating it for. These valid, I say with air quotes, these valid values aren't necessarily exhaustive lists. Particularly think about things like the sets of colors, the sets, the set of almost anything. People could say, well, you could add this or you could add this. We're not making judgments of what is a complete or incomplete set. We're specifically saying that as the designer of this class, for the purposes that I envision this being used for, I'm setting a set of valid values. For the purposes of this example, we're going to keep this simple. So we are only going to utilize 3 values for gender. Valid values are male, female, and unspecified. For those who do not identify as male or female, rather than give some more complete list that takes into account other gender identities. We're going to keep the list relatively small. One of the things based on this definition of the person is, as we're talking about the age in years, the concept of a negative age just doesn't make sense for us. Age must be at least 0, meaning, an infant under the age of 1. So we're going to make a comment here that valid values are positive and less than 128. The less than 128 has to do with the fact that it's a byte, not, again, any value judgment on what the maximum possible age for human beings is. We're just saying that we're willing to gamble with the concept that if someone's over 128 years old, that they will make a special accommodation without using this program. So in this case, we are going to set the first name property to the fn because, as I said before, we are not doing any data protection. We're totally cool with the idea of special characters and numbers in our name fields. but we are going to want to do some data protection on the gender and the age. So the passed in variable is called sex, and we are going to do sex dot equals male, or if sex dot equals female. And one of the things, just as a review from your basic course, remember that strings are indeed objects, and so we don't compare them with the double equals like we would with primitive types. In this case, we're just going to use the dot equals, unspecified. So if it's one of our valid values, then we'll let gender equal sex. If, however, it's something else, like maybe Fred, for the purposes of this application, Fred is not a valid gender, so we will throw a new illegal argument exception with our own defined message that states all person objects must have a gender of male, female, or unspecified. Put the or in there. And again, as a refresher, remember, because quotes within a string would designate the end or the termination of that string, we have to escape or slash any quotes within the string. So for the purposes of this, that's why we have the slash quote male, slash quote female, slash quote, and so on and so forth. And just as to point it out, remember, if you didn't know, like, how do I set my own custom thing in an illegal argument exception, I can go over here to java.lang, look at the list of exceptions. One of them is the illegal argument exception, and as I already indicated, one of the there's more than one constructor. The constructor is overloaded, and one of them takes in a string s, which that is a specified detail message associated with that illegal argument exception, so that the user on the other side will see it and understand why an exception was thrown and handled. And now, finally, for this constructor, we will deal with the age, and we'll say if age is greater than or equal to 0, then age equals age. Now, this is a construct that may look strange. You probably or may have been warned against doing this because it is confusing. Now, the Java compiler deals with this just fine, but there is a keyword or reserved word in the Java language that I'm very fond of for these kinds of cases. For me, I couldn't think of something equivalent to age that kind of made sense to me. So my property and my input are both labeled age. I can distinguish the two by using the this keyword. This refers to the object that is either being constructed or that has the instance method that you're writing it in inside of itself. That means the one that's the property is the one that corresponds with this. The one that's not marked that way is then the passed in argument. So that helps clarify what is indeed meant. And this is not an uncommon practice. I still strongly recommend, where possible and where it's relatively easy, to use a different variable name for what's passed in than what the property is. But if you can't come up with anything, this is a terrific way to deal with that. Again, if the person puts in a negative number, we'll put in an illegal argument exception, and we will specify our own message, and it will be all person objects must have an age of at least 0. Now you'll note I'm not dealing with the construct of it being over 128. That's because the byte itself won't take that, so I don't have to worry about dealing with it, because if they've passed us a byte, which, I made a mistake, which they have, as you see here, if it's made it to this place, we already know it's not over 128, because they couldn't have even called this method. Their program wouldn't have compiled, or the interface code side would have to have already taken that into account, because you wouldn't have even been able to call this method. So we only have to worry about valid values for the data type, and negative 127 through negative 1 are all valid values for a byte. So we do take that into account. One of the things that we need to document, in addition to the parameters, is if there are exceptions thrown. So there is an @throws tag in Javadoc comments that allows us to specify which kinds of exceptions are thrown, and then describe when those are thrown. We could say thrown when a value other than male, female, or unspecified is provided for the gender, or Actually, I'm going to go put that down here. Or a negative value is provided, use consistent language, for the age. So now we've specified what each of these input values is, what they're intended to be, and describing in our own words for the consumer of our class, someone who's going to make objects out of it, for them to have a good handle on when an exception would be thrown so that they know what to do with their try and catch statements. So, in the sake of brevity and not making this go on for longer than is necessary, I would add a third overloaded constructor, and the version of this application downloadable from the Canvas site does indeed have a version of the constructor that does take in a value for all 7 of these properties, so that the person who wants to add that information can do so. And one of the things that's nice is, you might be thinking, wow, do I need a constructor that just takes first name or one that just takes middle name? If you gave every theoretical possibility from 0 to all arguments, we'd have dozens of constructors, and that's really not necessary. Just as I supplied a null value to ones I didn't need, if someone, say, wants to add a courtesy title and a middle name but don't need to add a suffix, that can still come in, be sent in as null. There's no rules that say you can't send null in place of any object. We can send the nothing object or null in as the value, and then if they didn't want that to be valid, that could be handled with our data protection. Just keep that in mind. So there will be a third constructor on the version that's uploaded, but in the interest of time, we're going to leave that out in the live coding. We're going to move right on to our set methods. Now, one of the things by convention you'll see is it's good to keep consistency with the ordering of our variables throughout the application. That if we're working with first name is first in all of these places. So we'll make a public void set first name that takes in a string fn as input as the first set method. And just like above, as we've said before, we are not doing any data protection here. We'll take any valid string and just automatically set it. One of the things that's nice here is this will be relatively concise. We'll say a method to set or update the person object's first or given name. And I'll put a little space in there before the at param fn, the first or given name of the person object. One thing I highly recommend, if a parameter is used in more than one place, say in the set method and in the common property constructor, and it will be in the complete property constructor as well, keep the definition language the same. Be cognizant and of your consistency, because it's more user friendly from a programmer standpoint. The user of your class, the consumer of your class who will be creating objects, to understand that, exactly when they see FN, exactly when they're dealing with presumably a first name type property, that that they're given a consistent definition. It's very professional. So I just highly recommend that you keep that in mind. Since we're doing no data protection, there is no throws tag. So we can move right on into our public void set last name. You'll remember, hopefully, from your intro class, or you'll just notice from what I'm doing and what others have done, that by convention our set methods begin with a lowercase set and then have a leading caps version of the property name. This is a naming convention that is very consistent among all Java programmers, just like properties and method names always start with the first word being lowercase and each consecutive word have a leading cap. That's a convention that you will see universally maintained within the Java programming community, but you'll probably remember that there are other things we can technically do with our variable names, and they'll still be valid, compile, and work just fine. But now that we are in an advanced class, we will be almost always sticking to regular conventions that are common among all Java programmers. So again, no data protection, we'll do last name equals ln, and we'll go up and do our real quick Javadoc comment, a method to set or update the person object's last or family name. The empty line that I like to put in there at param last name, the just to make sure I get it consistent, I'm going to copy it. Oh, what'd I do? Shift. There we go. And I'll come down here and V. Again, keeping that consistency for the sake of making things easier. Now, these set methods are going to really work very much like these constructors. They're going to have the parameters defined, and they're going to have the throws if appropriate. So in the interest of time, to keep the lecture concise while still hopefully giving you all the information you need, I'm not going to go through the exercise of making the middle name, the courtesy title, the suffix, the gender, the age for set methods. The version uploaded to the Canvas shell has all 7 set methods. But I do want to cover the get methods before wrapping up this lecture. So let's create a method to retrieve the person object's first or given name. As you probably know from your beginning Java, your introduction, this will have a return type that will match the property, but it will have no arguments, so we will have no need for the @param. But what we will have need for is an @return tag that that sends back the first or given name of the person object, so that the end users are or the consumer of the class is fully aware of what what's coming back, because the Javadoc compiler will know that it's a string, but it isn't really going to know what that string is, and for the sake of this, that string is going to be the first name. And as you imagine, for all of these, they're going to be pretty standard. One of the things that is pretty common, no matter how advanced of a Java developer you get, your sets and gets, and even more so your gets than your sets, look very, very much the same all the time. Pretty much every single get you ever write will be public data type get variable name, no arguments input, and the only line will be a return and the value. It does not need to be it doesn't need to be fancier than that, because all we're doing, we don't have to do any protection, we don't have to do any extra stuff. If we want the end user to be able to see the value of that particular property, then we provide the get. If we wanted to keep them from seeing it, we would just not create the method at all. So it's very rare for these to be more complicated than this. But I did want to make sure you were comfortable with this idea of having the return tag in there, so that you can do that in your own code and kind of get a handle on what is common inside these Javadoc comments. Now, as I said, this is a very simple class definition for a person type. We have seven properties. We're going to have 3 constructors, 7 set methods, 7 get methods. At this point, we don't need anything else. So for the purpose of this class, I am going to save this work so that I can show you how it all comes together, particularly from the Javadoc standpoint. So I'm going to invoke the Java compiler against my person code, and assuming I didn't make any mistakes, which I did. I misspelled the word courtesy title. Right there. And now that matches. Whoops. Delete courtesy title. Let's save that. Since I am in the habit of always doing live examples, I believe it tempers the speed at which you can absorb the material. You can understand what I'm doing rather than me just pointing at a bunch of pre-written code. I will sometimes make syntax errors, but those both give the ability, not in this case, but sometimes the ability to see some debugging, live debugging going on, to learn those skills or see examples of those skills. And also it just reminds you that no matter, again, how advanced of a programmer you are, you're going to make syntax errors in your code. So that did compile. We don't run it. This is a consumable class only. This is a definition of the set of all person objects. It is not intended to be run on its own. It is typical, and you probably did this in your intro class, to create a test application that utilizes the different methods just to make sure it works. That is something you are going to want to do in practice. You are going to want to create, particularly when you do, when we get into the homework, and you write a class that is not in and of itself runnable, you're going to want to create a runnable program that tests your code, because, again, no matter how confident you are, you may have made some logic mistakes, and it would be embarrassing for someone else to go to use or consume your class and not have it work at all. So it's just good practice to create a test application to go along with it. I will upload a test person application to go with the person class, so you can see how that's done. The more interesting thing I'd like for you to see at this point is the Javadoc person.java. Javadoc comes naturally with the JDK when you download it from Oracle, and you will see I made a mistake somewhere on line 80. The parameter here of @param ln, it doesn't like it, so I did something wrong. Whoops. So let's look here. ln, let me just make sure that this is ln, and let me make sure this is ln. Whoops. And let me make sure this is ln. that none of them are one ends. I may have mistyped at some point. It still does not like it. Oh. So what I see here is that actually my error isn't that there is not a last name, that I did this wrong. What I'm finding is that I accidentally didn't close my Javadoc comment. So that actually could cause problems also with the compiled code, even though it did compile. So in fixing that, I'm going to go back and I'm going to recompile the person class, to make sure that didn't introduce any new errors, and also to make sure that the bytecode of that person class works properly. Now let's redo the Javadoc comments. No errors, no warnings. And the interesting thing is in all of this word stuff here, you'll see a number of HTML pieces were built here so that to create the set of documentation. So going in here to where that is at, you'll see a series of HTML pages and a JavaScript file and a cascading style sheet. If you're not, if you don't have a background in web development, these things may not mean that much to you. But these pieces, in particular, and all the stuff it created up here, all combine to give us the look and feel of the API documentation that we've been looking at. You see what we've got here. Now look, when I click on index, what we see is a person class. It tells me that it's a person class. This is what's called an inheritance chain. We'll be talking about that a little bit next week. It talks about the fact that this is a public class person that extends java.lang.object. Again, that piece we'll talk about next week. Here's the first thing that's actually code or comments that I typed in, the overall description that I put in at the top of the thing. This is a simple class definition that shows up here, and that's the first thing I've done. Now, whether or not I put this / constructors, that's something I did because I like to separate it. It just knew what my constructors were, because constructors are always have no return type and are named the same as the class. It knew person and person were both overloaded versions of the same, of constructors for this class, and it was able to grab that information and share that here in the constructor summary. So this doesn't have all the parameter information in it. It's the summary. But these hyperlinks here will jump me down to where the details are. Everything I did is an @param with a name and a description were put down here with that nice little dash to separate them. Those are all my parameters or arguments. Any exceptions, they go down here in the throws because I did the at throws. And it shows my description because I know what is meant by that. It knows how to organize it because of the fact that there are 4 arguments here. If I would have got a warning or error had I missed any of these. So anyone using this, they don't need to know anything about data protection. In particular, this information is all they need. They don't need to know how I wrote it. They just need to know that there's a constructor that takes in 3 strings and a byte, and these are what are intended of those strings and the byte, and what they need to do for tries and catches, and that's all they need to know. The same thing for the methods. You'll notice there's a method summary, and you'll see there's the get, the 2 gets, the 2 sets. Now you'll notice it did this in a different order than we wrote them in there. Here they're alphabetical, particularly in more complex classes with large sets of methods. It's easier for a user to find things alphabetically, whereas you as a coder may organize them in a different way. I tend to like to put my sets first, then my gets. That's just a personal thing. This is alphabetical. We'll talk more about these inheritance methods again in the next time when we talk more about inheritance. But again, just like above, if I tap on the name, I can go down here and get the details. What it is, and what is returned. What comes back. So hopefully this all makes sense. You can find now a version of the full class in the course shell in Canvas. If you go and log into the class and you go to Pages, View All Pages, Examples, this will be a growing list. You can click here and download the code of a complete version. It tells, the reason I use a page rather than just the files, you can get it you can get it right there as well, is when I do it from an examples page, is particularly if you missed a lecture, you haven't had a chance to look at it, whatever it is, you can see what this, or if you just forget, you watched the lecture 3-4 weeks ago and you're in here, it reminds you what this is, and the date corresponds to the in-class lecture. Most of you watching this video will be online students, but you certainly are always welcome on Wednesday evenings, 6 to 8:50, to come to class. This time period just refers to the Wednesday in which this was covered in class. So you can grab the full example and look at that and work with it on your own. I hope you have enjoyed our initial lecture on encapsulation and seeing how Javadoc comments support that hiding of the implementation from the utilization of the class and its methods. You will have an opportunity to see how this works in action when you get to utilize another student's class, a class that they make with Javadoc comments, to be the consumer of code you didn't write, but that another student did. That will be coming in the upcoming weeks. Take care and talk to you soon.